This series of videos talks about community detection in networks. Here's an example of a network with a natural community structure. There are three denser networks that are loosely connected to one another. Here is a real-world network with strong community structure. The Santa Fe Institute is a scientific research center in New Mexico. In this network, the nodes are researchers, and the edges correspond to co-authorship. The community detection method split this network into 7 communities. Afterwards, the areas of the network were labeled to show that the communities identify research groups at the institute. Here is a small social network that played a classic role in the development of community detection. In the early 1970s, sociologist Zachary was studying a karate club, keeping track of social interactions. During Zachary's study, a conflict arose between the president and the instructor, and the club fractured in two. 25 years later, Girvan and Newman used this example in their early work on community detection methods. Their hierarchical clustering method correctly predicted the actual split from the network data. It has become a favorite example ever since. Here's the actual split of Zachary's karate club, as well as the community detection result. And fun fact, there is now a Zachary Karate Club. The first person to use Zachary's Karate Club at each network science conference is added to the club. But in reality, social circles can overlap. So it is worth mentioning that researchers have also developed methods to detect overlapping communities. This is an even harder problem, and so we'll stick to the easier problem of partitioning the network into separate communities. There is a related network problem that deserves our attention first, the graph partition problem. This problem predates network science by nearly 3 decades. Given the graph, we want to split it exactly in half. Our goal is to find a split that minimizes the number of edges that span the two parts. Both the graph partition problem and the community detection problem split the graph into subgraphs. So let's highlight the differences. In graph partitioning, the number of groups and the size of the groups are given up front. We want to find the split that minimizes the number of crossing edges. In community detection, the number of communities and their sizes are unspecified. These are attributes that we must discover. Our general goal is to find a split so that the communities are relatively dense. They should have lots of internal edges. And we also want cuts between communities to be relatively sparse. There should be few such edges. With so many unknowns, community detection is quite difficult. And the bad news is, graph partitioning is already known to be NP-complete. This just means that it is a hard computation problem that takes a long time to solve. So we must turn to approximate algorithms instead. So let's talk about the Kernighan-Lin algorithm, which is a local method, meaning that each calculation just looks at vertex neighbors. There are also spectral partitioning algorithms that use the whole graph at once to make an approximation. I'm going to give a quick rundown of the Kernighan-Lin algorithm. I've linked to a couple of videos that give a really nice description of the algorithm itself. The KL algorithm proceeds in rounds. We start with a partition into 2 sets, A and B. We note the size of the cut, which is the number of edges from A to B. We then find the best pair of vertices to swap between these sets. We find the greatest reduction in the cut size. We swap these vertices and then lock them in place. Then we swap another pair, and so on until we swapped every vertex. And note that in some of these swaps, our partition can actually get worse. We then look back at every partition we considered during the round, and we pick the best one. Then to begin the next round, we unlock all vertices and do it again. We repeat round after round until the algorithm no longer finds an improvement. Kernighan-Lin does well in practice, but it is a slow algorithm. And that's all that we're going to say about graph partitioning, except to note that the Kernighan-Lin algorithm is going to make an appearance in the community detection algorithms that we discuss in later videos.